We are now going to talk about limits algebraically, and sometimes this is also called finding limits analytically. And this is a little bit more challenging than finding limits graphically, since this one doesn't have that visual aspect that the graphical ones do. So instead, we have to utilize our wonderful algebra skills in order to evaluate the limits. But first, just a quick refresher. What is a limit again? Well, it's the y value that a function approaches at a given x value. So the way we're going to start each of these problems is by simply doing direct substitution. Now, if this works and we're able to get an answer, we're done. It's that simple. However, there are many cases where, of course, direct substitution will not work, and this often is shown in rational expressions that have a 0 in the denominator. Now, if it gives you an answer where it's a 0 over 0, this is called indeterminate form. And basically this means we need to manipulate the equation algebraically in order to be able to evaluate it here. And there's 3 different methods I'm going to talk about in this video. So if it can't be directly substituted into its current form, one of the ways we might try to manipulate it is to factor and cancel. Another method is to rationalize if we have any radicals. And the third way sounds kind of vague because I just call it simplify, but a lot of times if we have complex fractions, like a fraction inside of a fraction, we're going to look for that common denominator so that we can simplify some of the fractions and hopefully somehow eliminate what's causing the problem in the denominator. There's also a 4th method called L'Hopital's rule, but we won't learn this until much later on in the semester. So for today, these are our different methods. And if we do these correctly, then this should allow for us to simplify and then use direct substitution in order to get to our happy place, aka evaluate the limit. So we're going to go through 6 examples in all. Some of them will be much faster than others. So let's take a look at the first one. Alright, so the limit as x approaches -1 of the expression x squared plus 3x minus 6. It is kind of just good manners, good math manners, to put parentheses around things like this when working with limits, just to be super clear of what it is you're taking the limit of. Another thing I'm going to ask you guys to do as you work through these algebraic limits is to do your work going down below versus going across. A lot of times when we go across, we get these chains of equal signs, and on the AP exam, if you make one little mistake in just one of those steps, since you're saying all of these things are equal, then the entire statement you've just made and chained together with these equal signs now is completely untrue. So to avoid that, we're going to show our steps vertically. Now, I know I just said this, and this seems like, Miss Wright, you just said not to do this. But anytime I'm just doing simply direct substitution, I do go ahead and just put it directly next to the limit because I'm no longer simplifying the limit, I'm just plugging it in. So if we do direct substitution here and just plug in the value, okay, and simplify, we're going to get a positive 1 minus 3 minus 6, which will simply give us an answer of -8. Okay, so in this one, direct substitution was all we had to do. Nice and easy. On to our second example. The limit as x approaches 3 of the square root of x plus 1 divided by x minus 4. So again, I'm just going to go straight into direct substitution to see if that will work for us. and I plug in my 3, and we'll be able to simplify this to square root 4 over negative 1, which is just going to give us an answer of negative 2. So far, so good. Alright, so this is the first one where we have a denominator to worry about, and I'm sure you can see that if I did direct substitution here, we clearly are going to end up with 0 in the denominator, which is undefined. And in fact, if we look at the numerator, it would also simplify to a 0. So this is that super common instance of the numerator and the denominator both evaluate at a 0, which is that indeterminate form, which means we got to do something else. So a lot of times the first thing I'll go for is to try and factor, just because we're pretty trained to do that anytime we see a quadratic in the numerator. So let's go ahead and factor 2x squared minus x minus 3. And I'm going to kind of come down here and do it off to the side. Okay, so I'm just going to use the area model for this and the little x factor. So it has to multiply to negative 6. And it has to add to a negative 1. And the two numbers that are going to do that will be 2 and 3 if 3 is negative. So again, if you're new to the area model, it does not matter which of those two boxes you plug those two terms in. They work either way. Then if we factor the outside, the way I filled in my boxes, 2x squared can only be multiplied to with an x and a 2x. And since a 2x can't multiply to a 3, it's going to have to go on the side, which means we have to have x up here. Then you just fill in the rest. So 2x times what gives me 2x? That's just 1. And x times what gives me negative 3x? That's a negative 3. And then negative 3 times 1 should give me this bottom number in the corner, which it does. So this is going to factor into 2x minus 3 times x plus 1. Alright, so we know that this will factor into 2x minus 3 times x plus 1 divided by x plus 1. And again, you can keep this in brackets if you're being extra appropriate, but a lot of times with the rational you can get away without them. Alright, so as you can see, since it's factored and we're multiplying between these pieces, we're able to cancel those out, which means we're really finding the limit as x approaches negative 1 of simply 2x minus 3 over 1, which is just 2x minus 3. So now we should be able to do direct substitution without any problems. So just plugging in that negative 1, and we're going to get a negative 2 minus 3, which will just give us a nice negative 5 as our answer. Now notice that each line, as you're simplifying a limit in some way, should have this part written. I know it seems annoying to have to write it over and over again, but you have to continue to use that notation until the actual substitution step. This brings us to example 4. The limit as x approaches 3 of the square root of x plus 1 minus 2 all over x minus 3. So again, first thing you should always try is direct substitution. That's going to be the square root of 3 plus 1 minus, let me fix that, minus 2 over a 3 minus 3. So I can already tell that square root of 4 is 2, so 2 minus 2 is 0 over 0. Okay, so that means we're going to have to do something with this limit in order to evaluate it. Alright, so anytime you're trying to simplify something that has a radical, your brain should be going ding 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 ding, because that is pretty much always going to be the case where we have to rationalize. Okay? And when we rationalize with radicals, we're going to multiply by the conjugate of whatever expression the radical is in. And just remember that the conjugate means that you keep those same two terms, but change the sign in between. And so a common example you see in math class is you take two terms, like an A and a B. In our case, A and B are a little bit more complicated looking. And you multiply by the conjugate, which means you keep those same two terms but put a negative or the opposite sign between them, whatever that may be. So in our case, we'll actually be using a positive to be the opposite of the subtract sign. And the reason we do this is because when you actually distribute or multiply out conjugates, the middle terms always cancel out, leaving you with the first term squared minus the second term squared. And so basically, this helps us because it takes that radical sign and it squares it for us. Okay, so let's actually put this to use. So in this case, our conjugate will be that first term plus the second term. And if we multiply by that on the top, we have to multiply by that same thing on the bottom. So on the top, we know this gives us a squared minus b squared. So the square root of x plus 1 squared simply becomes that inside part, since the square and the square root undo each other. And 2 squared just becomes 4. And one thing I want to point out is I have some good news. You do not need to multiply this denominator out. Please do not do that. That is a waste of your time and energy, because we're just going to plug something into it. Alright, so if we clean up the numerator, we're going to end up with x minus 3, which makes us happy because it magically will cancel out with the x minus 3 factor in the denominator. And this leaves us with something we can use direct substitution with. So now we can actually plug in a 3, which will have us getting 1 over the square root of 4 plus 2, which is just 2 plus 2, which means we're going to get an answer of 1 over 4. Alright.